Hi students, today I am going to explain about Chattelier's principle, which is having its own name. When it will deal with the systems at equilibriums. That is the moment you see in CRE, often the equilibrium constant comes in place, which will decide the progress of the reaction and conversion. In such cases, Chattelier's principle is of good use. So the Chatelier principle talks this way. When an equilibrium system is subjected to stress, that means you are giving disturbance to the system, then the system will counteract the disturbance. It will try to nullify the disturbance that you have given. Disturbance can be of many types. You can disturb the system in terms of concentration, you can disturb the system in terms of temperature, and you can disturb the system in terms of pressure. All these three kinds of disturbances you can give to an equilibrium system. Then you can see that how the system will counteract the disturbance you have given. That is the whole concept of Chattelier's principle. I am explaining today with some very simple example where you can able to connect yourself. Very simple. Don't worry about the units. Don't worry about the conversion systems, anything. Simple. We will take a simple hypothetical reaction. Then we observe what is the importance of the Chattelier's principle. And let us consider the hypothetical reaction A reversible B. This is a reversible reaction. See, whenever the reversible reaction is there, Chattelier's principle will play a major role. Imagine the volume in which we are conducting the equilibrium reaction is of 10 liters. K is the equilibrium constant of this particular reaction, which is defined. You already know how to define the equilibrium constant. Concentration of the products divided by concentration of the reactants is my equilibrium constant. Don't neglect, we are not changing any temperature, we are not changing any pressure. So in such cases, the equilibrium constant turns to, you can see, concentration of the products by the concentration of the reactants, which is 1.5. I have taken it at random, 1.5. You can do this with another constant number also. Temperature is constant, pressure is constant. The initial moles, that means we have starting our reaction by putting A in the system. That is what initial moles of product is. There is no product in the system at the first phase. Simple, what I have taken 10 moles of A, I have kept in the 10 liter reactor. I wanted to see, because whenever you see the A, of course it is going to form B because it is a reversible reaction. We will see at equilibrium how much amount of B that is going to form. The calculations behind the numbers I am going to show in little further. Right now, take it as a granted. Observe what is happening. I have taken A of 10 moles, which is in a 10 liter reactor, which one concentration is 1 mole per liter. Don't worry about it. 10 moles of A. I wanted to find at equilibrium how much amount of B is going to form. So I have done some calculations. Based on that, I got A is 4 moles, B is 6 moles. That means some moles of A is reacted to form B according to the hypothetical reaction which we have seen. A gives us. It's our equilibrium. That means if you put A in the system, finally it is going to form this B of 6 moles. Now let us apply the Chattelier's principle. I am going to stress the system now. In which stress I am giving? I am going to give the stress of concentration now. Because you can give stress in many different ways. You can stress the system in terms of concentration, temperature, pressure. Now I am going to give the stress in terms of concentration. Imagine I took a syringe, A stress. That means the system which is at equilibrium, now I am disturbing with injecting more molecules of A. So what happens? Initially 4 moles of A, 6 moles of B are there. Now I am putting 2 moles of A into the system. Now our total moles of A is 4 plus 2, which is 6. Total moles of B is, which is 6. Now I have stressed my system. So after, what happens? Some reactions happens between these two. Finally, it comes to another equilibrium because I have kept more molecules of A. You can see after injecting the molecules of A, this is the A molecule. This is a 4.8 moles. B is the 7.2. So at equilibrium, it is going to have 4.8 moles of A and B is 7.2 moles. Okay, what you have observed here? Because you kept stress in terms of A, see what happens to my product? From 6 moles, it goes to 7.2. That means when you stress the system in terms of reactant, if you're giving too many moles of A, the equilibrium will takes to the more product side. So that is why you can see more moles of B has been formed, which is 7.2 compared to 6 here. Let us give another stress. The system which is equilibrium at this point, I am giving stress in terms of B now. That means I have injected 3. That means I have injected with an injection, okay, 3 moles of B. What happens now? The system consists of how much? The system consists of A consists of 4, which is as it is. B is 9 now. I have given more. See, after I have done some calculations, what I am observing here. Now A is 5.2, B is 7.8. What happened? That means if I am injecting more product into the system, now the equilibrium will shift. It will try to form more reactants now than the product. See here, if I am injecting the reactant, it tries to form more product. If I am injecting product, I try to form more reactants. This is what the Lee-Chatelier's principle. That means that's what the definition. If you give the stress to the system, it will counteract that stress. The stress in terms of A will form B. The stress in terms of B will form A. This is the whole idea of Lee-Chatelier's principle. Today I have explained you the effect of concentration. Pause. Okay. See, what is happening in all the cases? Sometimes you are finding that reactant is forming. Sometimes you are finding that the product is forming. What the system is doing here? You see, the value of the equilibrium constant is 1.5. So no matter how much stress you give to the system, it always tries to maintain this 1.5. I'll prove you. See, what is the at equilibrium? What is the K value here? 6 by 4, 1.5. See, at this equilibrium condition, what is my K value? Which is 7.2 by 4.8, 1.5. At this condition also, what is my K value? Which is 7.8 by 5.2, which is 1.5. That means this is what the beauty of the equilibrium constant. No matter how much a reactant and product is there in the system, when you try to disturb the system, the disturbance will always take back to the equilibrium constant, which is 1.5. That is why it is called equilibrium constant. Understood? Pause. Okay. Now let us see how we have reached the values of 4 and 6. Because you have started with some A, which is of 10 moles. At equilibrium, you are going to have 4 moles of A and 6 moles of B. This is the procedure. And let us say volume of the reactor in which we are conducting reaction 10 liters, because volume has to be taken into consideration. Can you try to find the concentrations? Right. Let us take the values. A equal to 10, B equal to, we have to find out how much it is going to form at equilibrium. See, initial moles of A is equal to 10. Initial concentration of A is equal to 10 by 10, which is 1 mole per liter. Initial moles of B equal to 0. That's why its concentration is also 0 before it goes to the equilibrium stage. At equilibrium, let us assume X moles of A is getting reacted. That means X moles of B is getting formed. That means now the total moles of A at equilibrium condition, 10 minus X. Total moles of B at equilibrium is equal to 0, which is the initial stage 0 plus X. Concentration divided by 10, you get the moles to the concentrations. See, now you know the equilibrium constant K, which is defined at concentration of B to the concentration of A, which is 1.5. That is by X by 10, 10 minus X by 10. Once you solve this equation, you are going to find out X is equal to 6. Now you substitute in this total moles of A is equal to 10 minus X. That means 10 minus 6, which is 4. Total moles of B is equal to 0 plus X. That means total moles of B is equal to 0 plus 6, that is 6. That is how we have got this value. That means if you start a reaction which is not at equilibrium, after equilibrium, let us start with 10 moles of A. At equilibrium, it is going to form 4 moles of A and 6 moles of B. Okay, I hope this is clear. Now in the next step, I am going to make you understand stress part. That means I am injecting the system which is at equilibrium with 2 moles of reactant, which is A. Then we are going to see at equilibrium A equal to 4.8 and B equal to 7.2. This is what calculation I'm going to show now. Okay. Now we have seen how we have reached to the point, equilibrium point, which is A consisting of 4 moles and B consisting of 6 moles. Now I am giving stress in terms of reactant. I am injecting 2 moles of A into this equilibrium chamber. Now if I inject 2 moles of A into this equilibrium chamber, that means I have given stress. Now after it, what is going to happen? After injecting 2 moles of A, the equilibrium condition again it will be changed, which is A is 4.8, B is 7.2. See, after injecting, what is happening here? And more product has been formed because you have given stress in terms of reactants. The equilibrium constant will take that to the more product side. That's what has been observed, 6 to 7.2. This is how it is attained. Let us say this is our equilibrium condition. Disturbed condition is A, 4 plus 2. That means I have injected 2 more moles of A into the system. Now A is initial moles is 6, B is initial moles is also 6. So that is why it's 6 and it's 6. The concentration is 6 by 10, which is 0.6 mole per liter. And here also the concentration of B is 6 by 10, which is 0.6 mole per liter. At equilibrium condition, X moles of A is getting reacted, means X moles of B is getting formed. Now the total moles at equilibrium of A is 6 minus X. Total moles of B is equal to 6 plus X. If you convert this into the concentration, and moles by volume which is 10, if you divide it by 10, it will convert to the concentration. Let us come back to the equilibrium constant, which is concentration of the products by concentration of the reactants. You are not changing pressure, you are not changing the temperature. What you are changing, whatever the things you can see, the equilibrium constant is 1.5 only. Whether you inject more molecules in the system, you are not changing equilibrium constant there. So that is why it is again 1.5, 6 plus X by 10 by 6 minus X by 10. If you solve this equation, this 1.5 is equal to 6 plus X by 10 by 6 minus, you get X equal to 1.2. So if X equal to 1.2, the total moles of A at equilibrium is 6 minus 1.2, which is 4.8, and total moles of B at equilibrium is 6 plus 1.2, which is 7.2. That is how you got this number. See, 4.8 and 7.2. What is the ratio of 7.2 by 4.8? 1.5. That means again you see you disturb the system. Now system will again come back to the position which is the K is 1.5. Now here we have seen the stress in terms of reactant. So if this system is disturbed by the product, that means you have injected 3 moles of B into this system, what happens? See, 4 and 6 is my equilibrium state. I have disturbed my system with B. That means A is 4, B is 6 plus 3, which is 9. If you take this as a starting condition, you derive in the similar manner what I have done. You have reached to the value of, you will going to reach to the value of A equal to 5.2 and B equal to 7.8. In all the cases, if I calculate K here, 1.5. If I calculate K here, which is 1.5. If I calculate K here, which is 1.5. So the system will drive the things towards 1.5 equilibrium constant. Here, people talk about the shift. Now here, the system will more towards the product. Here, the system is more towards the reactant, because that is what is the Chatelier principle. When system is subjected to stress, then it will contract in such a direction to reduce the stress. Here you have given stress in terms of reactant, it goes to the product. Here you have given stress in terms of the product, it goes to the reactant. This is what the entire Chatelier principle. सब में हाँ बोलने का ना, आप कैलकुलेशन करो, गलती तो बताओ, नहीं तो मुझे कमेंट सुनना पड़ता है, ठीक है? यूट्यूब में जाएगा. थैंक यू.